watched another movie with him. What was it I watched?
With Jude Law?
No, I just watched another movie with Matt Damon.
Oh,
Trying to remember
the
what it
Bourne
was.
Identity?
Yes,
Oh,
yes,
yeah.
I just
Was it
rewatched
good?
that this weekend, yeah. Hi there. Welcome to Introductory Algebra at Portland Community College. I'm Ann Sittimer, and this is Candace Kling and Steve Simons. You'll be seeing a lot of us during this telecourse. You'll probably see us more than you'll see your instructor. Teaching math in a television studio has been a new experience for us. We're used to being in the classroom with students. But over time, teaching math through a television camera has gotten easier. I mention this because some of you will find algebra new and different at first. Yet we know that algebra will become familiar to you in the same way as teaching algebra in this new setting has become familiar to us. Candace, Steve, and I will present one part of each lesson. Here in the studio, we've got this desk with a computer. If I'm presenting my part of the lesson, I'll be at the desk. Usually Steve is in the studio with me, and Candace is in the control room with the producers. They're making sure I don't make any arithmetic mistakes on TV. The examples I'll be working show up on this computer monitor, and through the miracle of television, you will see these examples behind me, where the blue curtain is now. This monitor allows us to write our solutions directly on it, so you'll see us work through a problem solution as we discuss the strategy. Let's see what this all will look like.
Congratulations on taking the first step on an independent learning journey. There are several materials you need for success in this class. You need to rent or record the lessons. Additionally, you'll need to purchase the telecourse packet, the textbook, a ruler, a scientific calculator, and graph paper. The telecourse packet includes a syllabus with contact information for your instructor, a schedule for the course, homework assignments, testing information, resources for help with the material, and other information your instructor feels will help you succeed in the course. The actual instructor of the course changes from term to term. Information about the instructor can be found in the course syllabus. Your instructor will be administering and grading your tests and other assignments. Your instructor is also available for help with the materials. If you have not yet registered, please visit www.pcc.edu and follow the appropriate links for registration information.
As in all things in life, your chances for success in this course are greatly improved if you keep a positive attitude about the class. Math can be really frustrating at times, so it's sometimes difficult to keep a positive attitude. It will help you if you keep in mind that everyone struggles with math from time to time. It also really helps if you remember that it's not only okay to get help when you need it, it's a really good thing to get help when you need it. Another thing that helps is if you keep your materials organized. Find a strategy that allows you to easily find your notes, homework, and other important course materials. You need to make sure that you actively watch the lessons. For one thing, you need to have your notebook and a pencil ready for action while watching the lessons. When you watch us write the solution to an example, you want to pay attention and copy not only the answer, but the entire solution process. We consistently show the steps and organizational strategies that you should follow when writing your solutions. You want to budget more than 3 hours per week for watching the lessons. While watching the lessons, you want to actively work the examples along with us. You should sometimes even freeze the video before or after we work an example and try working the example yourself. This can help you identify whether or not you really understand what is being illustrated. It helps a whole lot if you read the relevant section of your textbook before watching the lesson. While you're reading, you should even try working the examples in the text. Now, having said that, it's important that you cut yourself some slack if you don't understand an example. If nothing else, your attempt to work the problem will help you identify important information in the videotape lesson that you might not have recognized as important without considering the material ahead of time.
This might sound obvious, but you need to do your homework. One thing that will help keep you on task is an established schedule that you can stick with. You should budget 8 to 12 hours of study time per week, above and beyond the time you spend watching the telecourse lessons. You need to do your homework regardless of how well you understand the lesson. Working your homework assignments is the most important part of the learning process. Genuine understanding of the material frequently doesn't even begin until you've attempted some problems. Even making mistakes is part of the learning process, and working through the mistakes ultimately leads to greater understanding. Sometimes you'll need help to work through the mistakes. If you find yourself really frustrated, it might be a good idea to take a break. Everybody gets frustrated at times. The best way to get past the frustration is to get some individual help. There are all sorts of people at PCC who are available to help you be successful. Please take advantage of this help when you need it. The clearest sign that you really understand the material is being able to work problems without looking at examples. It's a great strategy to look at examples when you are first working problems, but you need to get to the point where you can work the problems without looking at examples.
I've encountered many students in the classroom who have clearly put in their study time, completed all of the homework successfully, but still end up not doing well on the test. We certainly don't want this to happen to you. So let's talk about some of the obstacles and some of the things you can do to overcome them. If you are in the habit of keeping up with your homework, that's great. Doing your homework on a regular basis is the most important preparation for taking a test. It's also important to memorize key definitions, facts, and strategies. Many students find flashcards useful for this. It's a really good idea to create practice tests. Copy onto a piece of paper a representative sample of problems from each section of the book that will be covered on the test. Make sure you mix up the problems and include the types of problems that are most difficult for you. On another day, sit down and work the problems without looking at any notes or the textbook. Try timing yourself as if you were actually taking the test. An added bonus of a practice test is that it will help you identify the types of problems you need to spend a bit more time practicing. Now the real test. The most important thing is to relax. When I get exam, before I even look at it, I take a few deep breaths and remind myself that I'm capable of doing well. When starting the test, it's important to read the directions in each problem before you start to work any problems. Work the problems that seem quick and easy first. Then go back and work the problems that require more time. Watch your time and pace yourself. This is a lot easier to do if you started with the problems that are quick to solve. If you get stuck while working on a problem, stop and try working on another problem. Return to the problem that stumped you later. Finally, when you finish a problem, particularly an application, make sure you answer the question asked. Always check your work. Throughout these lessons, Steve, Candace, and I will show you many strategies for checking your work. This may sound like a lot, but when you're preparing for a test, you can practice some of these test-taking strategies. Taking tests well is a skill you can practice just like any other skill.
A lot of people feel that they just can't learn math. That's not the best attitude when you're trying to pass a math class. We can't promise you that it will be easy to learn the math, but we know that you can be successful. It's really important that you know and feel that you can be successful too.
A lot of people even say that they hate math. It's really tough to learn about something that you hate. It helps a lot if you look for the things you like about the subject. We've tried to present the material from a variety of perspectives so that everyone watching the series can find things they relate to. We've worked as a team to develop consistency, but have also maintained some individuality to allow you exposure to different perspectives.
Ultimately, the most important person in this course is you. With proper preparation, a positive attitude, a good work ethic, and a willingness to seek out additional help when needed, you will be poised to succeed in this and any other math class you choose to take. I'm going to turn it over to Candace now so that we can get started on the math.
Today we're going to talk about fraction arithmetic. Fractions are important in algebra because the ideas and principles behind fractions are used over and over again. I'm going to look at multiplication and division in quite a bit of detail and show why some of the rules work the way they do. Pay particular attention to the steps in my arithmetic because these are the steps you should be following in this class. This will help you keep your work organized and make it easy to read, especially later in the term when we look at more complicated problems. Next, Anne will look at addition and subtraction of fractions, and Steve will end this lesson with some application problems involving fractions. I'm going to start by looking at what we call fraction bars. and then do some review of multiplication, simplifying, and division of fractions. We're also going to review reciprocals. So let's start by going over fraction bars. If I want a picture of a fraction, I could start something like this. This is a bar representing 1, and it's broken up into 4 equal parts. So if I wanted to represent 1/4, I would need to shade 1 of the 4 parts. This is another way I could represent 1/4. Here's a third fraction bar, also representing 1/4. Each of these fraction bars represents 1/4. They come in different shapes and different sizes. The important thing about these fraction bars is that 1 of the 4 equal parts is shaded. Here's another bar. Let's say this represents 1. It's also broken into 4 parts. The problem is this is not divided into 4 equal parts, so we cannot use this one as a fraction bar. Well, how do we represent improper fractions with fraction bars? Let's consider the fraction 9/7. This is called an improper fraction because the numerator is larger than the denominator. Another way I can write 9/7 is 1 2/7. So if I start with a fraction bar and I have 7 equal parts on this fraction bar, and I shade all 7 parts, then I have 1 whole fraction bar, 1 unit. And 1 is the same as 7/7. This isn't enough. I need 9/7. I need 1 2/7. So if I get another fraction bar, also broken into 7 equal parts, I would need to shade 2 of those parts. So it takes 2 fraction bars to represent 9/7, or to represent 1 2/7. Now I want to review multiplication. Let's start with just multiplying 2 whole numbers. A whole number is 0, or the counting numbers. So 0, 1, 2, 3, 4, so on are the whole numbers. So if we're multiplying the whole numbers 3 and 4, we all know 3 times 4 is 12. But let's think about how we consider multiplication. 3 times 4 can be thought of as 3 occurrences of 4. With pictures, I can start out with 4 objects, and I need 3 occurrences of this. And as we know, 3 times 4 equals 12. Well, what if we throw fractions in? 1/2 times 4. I can think of this as 1/2 an occurrence of 4. So if I start out with 4 objects, I need to take half of those objects. And we see that 1/2 times 4, or half of 4, is 2, which we probably already knew. Well, what about 3 times 2/5? This I can think of as 3 occurrences of 2/5. So this time I start out with a fraction bar broken into 5 equal parts. I want to represent 2/5, so I need to shade 2 of the 5 parts. Now I need 3 occurrences of 2/5. So there's 1, here's a second, and here's a third. Now I want to combine these together in a fraction bar or 2. So let's take the first 2 shaded blue parts, the second 2, and the third 2. And this actually overlaps into a second fraction bar. So we can see from our fraction bars up top that 3 times 2/5 is, well, let's count the blue shaded portions. 1, 2, 3, 4, 5, 6. 6/5. An improper fraction. Another way I can write this is 1 1/5, which we can also see by looking at the fraction bars at the top. We have 1 whole fraction bar and then 1/5 of the second fraction bar shaded. Well, we have a property from multiplying a whole number times a fraction. For any whole number k and fraction a over b, where that denominator b is not equal to 0, k times a over b equals k times a in the numerator over b. We just saw that with 3 times 2/5. If we used this property, we'd have 3 times 2 in the numerator over 5 in the denominator, which is 6/5, the same thing we saw with the fraction bars. We also said we can write this as 1 1/5. Now I want to review reciprocals. The definition of a reciprocal is that the reciprocal of a number k is 1 over k, provided that k does not equal 0. So for instance, if I had the number 3, the reciprocal of 3 is 1/3. An important thing about reciprocals is that if you take a number and multiply it by its reciprocal, you always get 1. We're going to come back to this idea. Now I want to look at multiplying two fractions together. We can think of 1/5 times 2/3 as 1/5 an occurrence of 2/3. So I'm starting with a fraction bar here, kind of a large fraction bar representing 2/3. And the reason that I've started out with such a large fraction bar is that I want to take this fraction bar and break it into fifths. Since my thirds are set up vertically, I'm going to break it into fifths horizontally, like this. And I want 1/5 of an occurrence of 2/3. We can see this by the red portions at the bottom of this fraction bar. So looking at our fraction bar, we see that 1/5 times 2/3, or 1/5 of an occurrence of 2/3, is the two red portions out of a total of 15. So 1/5 times 2/3 is 2/15. We have a property for multiplying fractions. A over b times c over d is a times c over b times d. We multiply the numerators together and we multiply the denominators together. We just need to make sure the denominators are not equal to 0. So let's look at the example we just saw with fraction bars. 1/5 times 2/3. Applying this property, we multiply the numerators, 1 times 2, and multiply the denominators, 5 times 3. And what do we get? 1 times 2 is 2 in the numerator, 5 times 3 is 15 in the denominator. 2/15, the same thing we saw with fraction bars. Well, this property of multiplying fractions actually works if we have a whole number times a fraction. So we don't really need a separate rule for multiplying a whole number times a fraction. If we want to take a whole number k and multiply it by a fraction c over d, we can write k as k over 1 and multiply that by c over d. Again, our denominator d in this case cannot equal 0. Then we multiply the numerators, k times c, multiply the denominators, 1 times d, and what do we get? K times c over d. Same property we saw for multiplication of a whole number by a fraction. Reciprocals are multiplicative inverses. The number 1 is called the multiplicative identity because k times 1 equals k for any number k. Reciprocals are multiplicative inverses because when a number is multiplied by its multiplicative inverse, the result is 1, the multiplicative identity. K times its reciprocal, 1 over k, equals 1 for all k not equal to 0. For instance, if we had the number 4 and we multiply it by its reciprocal, 1/4, 4 can be written as 4 over 1, so we have 4 times 1/4. Multiplying the numerators, 4 times 1 is 4. Multiplying the denominators, 1 times 4 is 4. And 4 divided by 4 is 1. So a number times its reciprocal is the multiplicative identity 1, which means that a number and its reciprocal are multiplicative inverses. Now I want to look at some strategies for simplifying fractions. So the first thing in our strategy for reducing fractions or simplifying fractions is that we have a goal to find factors of 1 that are created by common factors of the numerator and denominator of the fraction. To do this, first we factor the numerator and denominator of the fraction into primes. Second, we locate factors that are common to the numerator and denominator. Each of these pairs of common factors can be replaced by 1. Well, let's see this in action. Let's say I want to reduce 12 over 32. So I'm going to start by factoring the numerator and denominator into primes. A prime number is a number that has only factors 1 and itself. 12, for instance, I can write as 2 times 6. 2 is a prime number. Its only factors are 1 and 2. 6 is not a prime number. 6 I can write as 2 times 3. 3 is also a prime number. 32 I can write as 2 times 2 times 2 times 2 times 2. Now I want to look for factors that are common to the numerator and denominator. And I see I have a 2 in the numerator and denominator. I'm going to pull that out. I have a second factor of 2 in the numerator, which I can pair off with one of the factors of 2 in the denominator. And that leaves me with a 3 in the numerator and 3 factors of 2 in the denominator. Now 2 divided by 2 is 1, so both the first and the second fraction can be replaced by 1. And when I multiply 1, our multiplicative identity, by this third fraction, it's not going to change the value of the third fraction. So this reduces or simplifies to 3 over 2 times 2 times 2, which is 8. Let's look at another example multiplying fractions. 2/3 times 3/4 can be thought of as 2/3 of an occurrence of 3/4. So I'm starting with a fraction bar representing 3/4. The fraction bar has 4 equal parts, 3 of those parts are shaded. Now I want 2/3 of an occurrence of 3/4. So I need to break this fraction bar into thirds. I'm going to do that horizontally. And I need 2/3 of an occurrence of 3/4. 2/3 of an occurrence of 3/4 can be seen by the pink portion here. So if we count, we see that 2/3 times 3/4 equals 6 pink parts out of 12 portions altogether. Now another way we can look at that is if we swap a couple of those pink rectangles with a couple of the blue rectangles in our fraction bar. Once we do this, it makes it a little bit easier to see that 6/12 is actually 1/2 of that fraction bar. So 6/12, as you probably knew, reduces to 1/2. Well, let's look at how we would do this without the fraction bars, using our property for multiplying fractions and then our strategy for simplifying. So when we multiply fractions, we multiply the numerators, 2 times 3, put that over the product of the denominators, 3 times 4. And knowing that I'm going to be able to simplify, I'm going to go ahead and factor the numerator and denominator into primes. The numerator is already factored into primes. 2 and 3 are both primes. The denominator has a prime number, 3, and then 4 can be written as 2 times 2. Now we see some common factors. I have a 2 in the numerator, which I can pair off with one of the 2's in the denominator. I have a 3 in the numerator, which I can pair off with the 3 in the denominator. And I'm left with a 2 in the denominator. And I'm going to write that under 1. 1 is our multiplicative identity. Multiplying 1 times 3, multiplying 1 times 2, or multiplying 1 times the whole numerator, 6, isn't going to change the value. So these first two fractions, 2 over 2 can be replaced with 1, 3 over 3 can be replaced with 1, and indeed this reduces to 1/2, which we already saw with the fraction bars. Now let's multiply 4/3 times 12/5. This time I'm just going to use the properties. I'm not going to pull out my fraction bars. This is what, in general, you'll be doing. So our property for multiplying fractions says multiply the numerators, 4 times 12, multiply the denominators, 3 times 5. And it looks like I'm probably going to be able to reduce here. To find out for sure, I'm going to factor the numerator and denominators into primes. So 4 is 2 times 2. 12 is 2 times 6, which is 2 times 3. The denominator has factors of 3 and 5, which are already primes. Well, it looks like I do have a common factor, just one. There's a 3 in the numerator and denominator. So if I pull out the 3 over 3, I'm left with 4 factors of 2 in the numerator and 5 in the denominator. Well, 3 over 3 is 1. Multiplying 1 by the second fraction doesn't change the value of the second fraction. And the second fraction has 5 in the denominator, and 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 in the numerator. 4/3 times 12/5 is 16/5. Now I want to review division. I'm going to start out with whole numbers again. Starting out with an easy problem we all know the answer to. We're going to divide 21 by 3. So I start out with 21 objects. I'm going to compare that to 3 objects. And what I want to decide here is how many times does 3 go into 21? So let's just count that off. 1, 2, 3, 4, 5, 6, 7. And as we know, 21 divided by 3 equals 7, because 3 goes into 21 7 times. Well, let's try that idea with fractions. Let's say I want to divide 3/4 by 1/20. So I'm going to start out with a fraction bar representing 3/4. So 3 out of the 4 portions are shaded. I'm also going to look at a fraction bar representing 1/20. The bottom fraction bar is broken into 20 equal portions, and 1 of those is shaded. And I want to know how many times does 1/20 go into 3/4. Well, let's count that off. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1/20 goes into 3/4 15 times. So we say that 3/4 divided by 1/20 is 15. Let's divide 2/3 by 2/9. So I start out with a fraction bar representing 2/3. 2 out of the 3 portions are shaded. And then I look at a fraction bar representing 2/9. 2 out of the 9 portions are shaded. This time I want to see how many times does 2/9 go into 2/3. Let's count that off. There's 1, 2, 3. So 2/3 divided by 2/9 equals 3, because 2/9 goes into 2/3 3 times. Well, we have a property for dividing fractions. A over b divided by c over d can be rewritten as a multiplication. A over b times the reciprocal of c over d, which is d over c. This time we need to make sure none of the denominators are 0. B, c, and d all show up in the denominators, so none of those numbers can be equal to 0. Well, let's look at the problem we just saw with fraction bars. 2/3 divided by 2/9. Let's use this property and see if we get the same answer we got with the fraction bars. So I can rewrite this division problem as a multiplication problem as 2/3 times the reciprocal of 2/9. And the reciprocal of 2/9 is 9/2. Our property for multiplying fractions tells us to multiply the numerators, 2 times 9, and multiply the denominators, 3 times 2. To reduce this, I'm going to factor the numerator and denominator into primes. In the numerator, 2 is already a prime. 9 can be written as 3 times 3. Both of the factors, 3 and 2, in the denominator are already primes. Now I'm going to look for factors common to the numerator and denominator. I have a 2 in the numerator and a 2 in the denominator. I have one of the 3's in the numerator that I can pair with the 3 in the denominator. And I'm left with a 3 in the numerator. And if you want, you can write this as 3 over 1. Then we have 2 over 2, which can be replaced with 1, 3 over 3, which can be replaced with 1. And when we multiply 1 by this third fraction, 3, or 3 over 1, it doesn't change the value. We just get 3 over 1, which is 3. The same thing we saw with fraction bars. 2/9 goes into 2/3 3 times. Now let's try dividing 5/7 by 1/2. This time we don't see a division symbol. This is actually quite common in algebra to use a fraction bar as a division symbol. Another way we could write this problem is 5/7 divided by, using our division symbol, 1/2. Generally, I'm not going to take this first step. I'm just going to read 5/7 over 1/2 as 5/7 divided by 1/2. Now, using our property for dividing fractions, I can turn this into a multiplication problem as 5/7 times the reciprocal of 1/2. The reciprocal of 1/2 is 2 over 1. So now we multiply our numerators, 5 times 2, and write that over the product of our denominators, 7 times 1. 5, 2, and 7 are all primes. Nothing's going to reduce here, so I'll just multiply, and I get 10 sevenths. Let's look at another one, 15 sixteenths divided by 3/4. So the first thing I'm going to do is rewrite this as a multiplication problem, as 15 sixteenths times 4/3. Multiplying the numerators, 15 times 4, and writing that over the product of the denominators, 16 times 3. This time it looks like I may be able to reduce, so I'm going to go ahead and factor the numerator and denominator into primes. 15 is 3 times 5, and 4 is 2 times 2. 16 is 2 times 2 times 2 times 2. And then the 3 in the denominator is already a prime. So I have a 3 common to the numerator and denominator. And I actually have 2 2's in the numerator that I can pair off with 2 of the 2's in the denominator. And that leaves me with 5 in the numerator and those last 2 factors of 2 in the denominator. So 3/3, 2/2, and 2/2 can all be replaced with 1. Multiplying 1 by that last fraction doesn't change the value of the last fraction. So our end result is 5 over 2 times 2, which is 4. 5/4. Now let's try dividing the whole number 2 by 3/4. 2 divided by 3/4. We can also think of this as a fraction divided by a fraction because we can write the whole number 2 as 2/1. So 2/1 divided by 3/4. So we can change this division into multiplication as 2/1 times the reciprocal of 3/4. The reciprocal of 3/4 is 4/3. Multiplying the numerators, 2 times 4, over the product of the denominators, 1 times 3. 4 doesn't have any factors of 3 in it, so I know this isn't going to reduce. 2 times 4 is 8, 1 times 3 is 3. So we end up with 8/3. Now let's look at a fraction divided by a whole number, 2/3 divided by 4. I can think of this as a fraction divided by a fraction. I can rewrite this as 2/3 divided by 4/1. The whole number 4 is the same as 4/1. Now I'm going to change this to a multiplication problem. 2/3 times the reciprocal of 4/1. The reciprocal of 4/1 is 1/4. Multiplying the numerators, 2 times 1. Multiplying the denominators, 3 times 4. This time it looks like I am going to be able to reduce. 2 is already a prime, so I'll leave that there. 3 is already a prime. 4 can be written as 2 times 2. And I have a pair of 2's, one in the numerator, one in the denominator that I'm going to pull out here. So I have 2/2 times 1 in the numerator, and I have a factor of 3 and the second factor of 2 in the denominator. 2/2 can be replaced with 1. 1 times that second fraction doesn't change the value of that second fraction. So this simplifies to 1/6. Now, one last thing I want to talk about is the transitive property of equality, because I've actually been using this over and over again as I've been doing some of these multiplication and division problems. The transitive property of equality says that if A equals B and B equals C, then A equals C. The transitive property of equality allows me to just stop on this last example at 1/6 and not have to go back and say 2/3 divided by 4 equals 1/6. We know by the transitive property of equality that 2/3 divided by 4, with all of those in-between steps, does equal 1/6. The other thing that I want to mention is that you might have thought, as I was going through some of these problems, is that I was going through them in an excruciating amount of detail. And indeed I was, and I did that intentionally. I started out this lesson by saying I wanted to review some of the principles of fractions, because these are things we're going to be using over and over again in algebra. And in algebra, we're not going to be able to do this work any simpler. With arithmetic, when we're just working with numbers, there are some shortcuts. Anne's going to talk next about adding and subtracting fractions, and at the end of her portion of the lesson, she's going to look at some of the shortcuts. But again, those shortcuts can only be used when we're working purely with numbers. As we go on in algebra, we're not going to be able to use those shortcuts.